Okay, so what will be taught today will be the I/O part, the circuitry inside the input-output port. How does the circuit inside the input-output port of your 8051 will look like? What are the components of it, and how does it work? That is what we are trying to study in today's session. So you need to understand that there is a pin which is forms the outside world, or which is connected to the outside world, and internally you have a latch which is used to store the values which goes to the pin and which comes to the pin. Now you have two connections out of this. One is reading of the pin value, second one is reading or writing into the port value. Okay, so when it comes to the pin, you can write into the pin only through the latch. That means only to this particular what is it, only through this particular flip-flop based entity. Here we have, it is being implemented using a D flip-flop. Each particular bit inside your pin, or each pin, is being connected to a D flip-flop. So automatically you have a latch, the D latch, which is being used as the storage device. So you can write into the latch or read from the latch, or you can read from the pin. So you cannot write anything into a pin. If you want to write something into the pin, it has to be through the latch. So there is only a write operation connected to the latch, whereas read has operations which are performed through the latch. That means you need to, if you want to read, you can read the latch value, or you can read the read pin. Okay, then this is your driving circuit. I'm not going into the details of it. It's something which you can analyze yourself using your electronic circuit theory. So you have pull up, you have a transistor, MOSFET transistor, which is grounded, and we'll see the inverse. So the idea that has to be conveyed, from the idea that has to be taken from this is that you have a pin which can be read, you have a latch which can be read, you have a driving circuit which drives the pin, and writing can happen only to the port. Now, each of these, all these are connected to the internal 8051 bus for the 8051 to read in things according to its requirement. It can read the particular port values, or it can write into the port value. So this is how your 8051 generically the port looks like. So it is connected in an open drain output form when operating as an I/O port. Now again, important point to be realized here is that your port can act both as an input port and an output port. Now when it acts as an input port, the values which are inside the pin has to be taken into the microcontroller. When you are acting as an output port, whatever the values which are there inside this particular latch or inside this particular thing has to be outputted. So you have two operations which are going to be performed as part of your input output pins. One is your input, the other one is your output. So I equal to 1, which means that if you want to make your pin input, you need to set the port as 1 values, and if you want to make the ports as output pins, you have to set the values as 0. That you will learn when you try to program your particular microcontroller. So need to understand all these concepts, that your port can act as an input or an output port, and each of these port pins can either be read or written. And when it comes to the pins, you have two connections out of it, the physical connections. One is a connection through the pin, the other one is the connection through the port. Now we will see each of the ports in detail. We'll discuss the basic details of how each of the ports will work. So this is the basic diagram of the I/O ports. Now we'll move on to each of the ports. So out of the 4 ports, the most easiest port is your port 1, because it acts only as an input output port. It doesn't have any other functionality to it. It acts only as a input output port. It can either read the values from the port, or it can write the values into the port. You will read 1s and 0s from the port, or you will write 1s and 0s into the port. So this is the only configuration, or only port which can do only this particular function. There is no other functionalities, or there is no dual functionalities associated with port 1. So we'll try to understand how a port 1 works. So this is the configuration of your port 1. As you can see, you have your latch, D latch here. You have the internal buses connecting. So this is connected to the internal bus, the D input. Now the latch is read through the Q terminal. So whatever be the value inside the latch will be read through this. This is shown as a buffer. All these are buffers. You have seen already the buffers which are there inside your 8051 block diagram. So this is a buffer through which you can read the value. So what is a high impedance buffer through which you can read the value. You can write the value through this particular pen into the latch, and it is all connected through these particular terminals. Now, if you want to read the pin value, it can be read through this particular value. You have a connection right across this, and you will be able to directly read the pin value which is coming here, whatever be the value. Then you have a transistor MOSFET, which will also have an internal pull-up. Now, how does it work? Consider that your port is acting as an output port. That means whatever is the value which is going to be written into the latch will be given out through this particular pin. Now, whatever be the value which is going to be written into the port has to be given out. Now, consider that you have written the value 0. That means you want the value 0 to be acting as the output, or the 0 should be the value which has to be outputted. So when the value is 0 in D and you give a clock pulse, the output of Q becomes 0, the output of Q bar becomes 1. Now you have a 1 here. You are having a 1 signal here, 1 digital value. 1 implies that this transistor is on. When this transistor is on, you have a direct connection through the internal plug, whatever be it, from the VCC to the ground, and automatically the value which will be present here will be 0. So that means whatever value that has been written here will be present at the pin, and you can take that particular value to the outside world through the corresponding circuits. So that is how you output the value 0. Now, second option is the output. You will be speaking about output and input. Now, first we are considering the output option, then we will consider the input option. Now, when your particular thing is acting as your output, so if the value is 0, this is how it works. Now, if the consider that the value is 1, when the value is 1 here, when the clock pulse is given, you will write it into the latch, and you will have 1 which is available at this particular. So using this particular latch, you can write the 1 value into the latch, and you will get the 1 output here, and you will get a 0 output. So 0 output implies that your this particular transistor is off, which basically means that you have the pull up and you don't have the ground connection, and you have the high value of VCC getting reflected at P1H, which implies that you will have a high output. So when this particular configuration of your particular port is output port, it can either take when it's 0, this transistor becomes on and the output will be 0 here. When it is 1, this transistor will be 0. That means it will be switched off. Basically means the VCC will be the value which will be outed here. So you get the 1 value. That is how it works in the output mode. Now in the input mode, when it comes to the input mode, you want this transistor to go off. Whatever the value in the P1H has to be read directly. So that means this connection has to go off. So input mode, always this particular port will remain as 1. That means when this particular value is 1, your output here will be 0, which implies that your particular this transistor will be off. So whatever be the value here will be read through this particular pin. So when you read the value through this particular pin, your particular connection, again, it goes to the D. So automatically the latch will also have this particular value. So you can read it through this particular pin, whether 1 or 0. So you have pull up. So accordingly, you'll have to give the voltage here so that it acts as a 0 and 1. That means this connection goes off. This becomes a open connection, and you don't have any connection between the latch and this particular point. So whatever be the value here will be latched into it, as well as you can read it from the pin or read it from the latch. You want the value directly, you can read through the pin. If you want it to be stored inside the latch and then read, you can read it through the latch. So the connection from the output of this particular latch to this particular thing is disconnected when it acts as an input. That means always the value, when it acts as the input, the value here will always be switched off, and the value which is present here will be read through this particular pin. So that is how the pin out or the pin configuration of your port 1 works. So this is a basic simple port which can act only as an input or output port, and it can act as both input and output port depending upon the value which is written into it. 1 signifies input, 0 signifies output. We'll see how it is done at the programming level. This is how it is, the working of this with respect to the circuit level or with respect to the transistor level is what I explained. I haven't gone into the details of internal pull up and all, which you can get, I mean, which the details which you can get from electronic circuits. So this is how your port 1 configuration of your 8051 works. Now moving to the rest of the ports. Now in the case of port 2, the additional thing that is required is, so you already know that in the case of port 2, it can act as an input output. So the basic connections always remain the same. The difference here is that there is no Q bar connection, but as you can see, you have a switch which is under the control. So you can either act as input output, or it can act as an address terminal. So you have a connection to the address or to this particular output. When it is connected to this particular pin, as you can see, you have a NOT gate, which means that we are not taking Q, we are taking Q bar. The rest whole circuit remains the same. So it functions as port 1 itself. When your control signal is connected, we are not, it may be either 0 or 1, whatever be it. According to the control signal, you have a switch, can be either connected to this or it can be connected to the address. So when it is connected to this, you have a NOT gate, which implies that the Q signal will be NOTed. Q bar connection is given to the gate of your particular N MOSFET, and then the working of it will remain as in your P1 case. But if it is to be used as an address latch, it will be directly connected to the address, and the values will be given through this particular terminal, and you are connecting it to a NOT gate. So accordingly, inverted logic has to be used to create the address. So this control pin will determine whether you are making it work as a simple IO device or your address or the utility of address location. So the basic things always remain the same. Port 1 IO setup will remain the same. You will have a circuit which will be used, or you will have a switch which will be used to connect either through the address or to the IO port. So that's with respect to port 2. Okay, moving on to port 3. Now, in the case of port 3, you are not only having the output functionality, you're also having the input functionality. So you have different ways in which the input can react. So accordingly, you not only have an output function, alternate output function, which is being employed, you have a NAND gate. So depending upon the value here, it can either directly connect it to this thing, or it can have a different function. And that particular different function is based on the input function that you determine. So input will be determined, or the way in which the input is taken is determined by these two values. So you have output function as well as input function. You have certain signals which acts as output, certain signals which act as input. So the functions, there is an option of giving both these controls in the particular circuit. But if these signals are not given, the common circuit remains the same. This is NAND. If this function is not significant, then it will act as a NOT gate. So accordingly, circuit remains the same. In the port 2 case, there was configuration only to the address location. That means it only acts as an address option. So that is why you had a control signal, and we selected between input, output, or address. Here, your functionalities associated with input and output. So you have a terminal for input function and also a terminal for your output function. So that's your port 3. And finally, your port 0. Port 0, I guess it also acts, if you go back to the previous slides, functionality of your port 0. So it can act as address or data line. So port 2 acts as address lines. Port 3 can act as different functionalities based on the selection of your particular input bar output functions. You had a choice of your output function and your input function. Port 1 was your IO function. Port 0 is AD. AD is, it can act as both address and data lines. So in the case of port 0 configuration, so again the same logic of your two ports, read latch, read pin, everything remains same. So if the value is 0, it basically means it has the same circuit as, but you don't have internal pull up. You are having a transistor which is acting as a connection here. So you don't have that internal pull-up setup in the port 0, but the rest all things had a pull-up option given to you. But port 0 doesn't have an internal pull-up. If a pull-up is required, you have to provide it externally itself. So when it is connected to 0, this is Q bar, not Q1. So this is Q bar. So automatically it will have the same connection as your IU. Now when it is connected to 1, it can act as address or as data. So you have a control signal which is used to select whether you are going for an address or data. So that is why you have an option of the control signal which is used to select between whether you are having a data or address. So you have the data line as well as the address line available to it. So depending upon your requirement, you can either make it into an address line or a data line. So your connection towards the address and data line in the case of your port 0. So this is with respect to your port 0. So when you try to learn learn this particular circuit, this becomes the basic circuit of your pin configuration. Rest all are based on the controlling activities. So you will have input output function control, or only the output control, or you will have address and data controls based on the requirements. So this is the basic setup of your pinouts of your ports which are being used as part of your 8051. So that concludes this particular module. We will move on to the programming of your 8051 or into your module 4 in the next class. So hopefully you have understood a little bit about what 8051 is, and that's it from today's lecture. I don't want to prolong my lecture. I have only discussed about the ports, the configuration of your ports, and mainly you need to focus on port 1 because it is the most simplest port, and the explanation of it gives the explanation details of most of the other ports. When you move on to other ports, you will have more control signals because it not only accesses bidirectional port, it also accesses other kinds of ports as well. So based on that, you will have different controls. For port 2, you have only address control. For port 3, you have input and output function control. When it goes to port 0, you have not only the you only have the input function control, but it can act as address as well as data line. So automatically you have different options coming into picture based on your particular interests or based on your requirements. So that's the idea which is being given here. So you have different kinds of, this is one kind of a diagram which I have shown. The textbook has a different diagram. You can use any kind of diagrams which can be used to explain this particular functionality. So that is it with respect to today's class. I am stopping today's lecture here. Vishnu, can you just give me the details of the attendees and absent?
Yes, sir. Yes, sir. Yes.
So the rest we'll take in the next class, and tomorrow you will have presentation. So all the groups which are ready for presentation can give their name so that the presentation can start. So make sure that you have contacted the guides and you had some interaction with the guide, and your PPTs are sanctioned by the guides. So I want at least 8 of you to present tomorrow, and the rest can present on Saturday. Am I clear? So the presentation will be for a duration of say 15 minutes maximum, 10 minutes ideally. Okay. If it is clear, you can put it in the chat box. If you have any doubts with respect to the presentation or anything with respect to the class which is being taken, you can put it in the chat box. I guess there are no notes. Okay. Okay then. Thank you.